Look down at the cracks in your garden path. Between the stones pushing through the gravel, sprawling flat across bare soil. There's a good chance something is growing there that most people spray, pull, or ignore without a second thought. Red stems, thick paddle-shaped leaves, a low creeping habit that seems to laugh at heat and drought. That plant is purslane, and if nutritional science is any guide, it may be one of the most valuable food plants on the planet. Purslane didn't arrive at your driveway by accident. It has been traveling alongside human civilization for millennia, cultivated, eaten, and valued across cultures that had no contact with each other, yet independently reached the same conclusion. This plant is worth keeping. Archaeological evidence places purslane seeds in northern Greece as far back as 1050 BC, stored deliberately in clay vessels. By the 4th century BC, the botanist Theophrastus was writing specific cultivation instructions for Greek farmers, placing it alongside staple crops rather than listing it as a foraged curiosity. The Roman Empire carried it across 3 continents. Medieval European households ate it regularly enough that a 13th century Milanese chronicler listed it among the city's core food supplies. In North America, the story is equally deep. When European settlers documented purslane in Massachusetts in the 1600s, they assumed it had arrived with them. Later archaeological analysis told a different story. Seeds found in Kentucky date to 800 BC, in Ontario specimens to around 1350 AD. Indigenous communities in the Eastern Agricultural Complex were cultivating purslane alongside sunflowers and squash long before any contact with Europe. 2 separate food traditions on opposite sides of an ocean, both independently determined that this plant deserved a place in the garden. That kind of convergent judgment is worth paying attention to. In 1960, physiologist Ancel launched a landmark study tracking over 12,000 men across 7 countries for 5 decades, searching for patterns that explain dramatically different rates of heart disease between populations. The results from the Greek island of Crete were baffling. Cretan farmers consumed enormous amounts of dietary fat, more than 35% of their daily calories. Every nutritional model of the era predicted they should have had catastrophic rates of cardiovascular disease. Instead, they had the lowest heart disease mortality of any group in the study, lower than Japan, lower than populations eating far less fat. For years, researchers credited olive oil, the monounsaturated fats, the Mediterranean dietary pattern. But when scientists went back to preserved blood samples from the original study in the 1980s, they found something more specific. Cretans had omega-3 fatty acid levels in their blood roughly 3 times higher than Dutch participants, without eating 3 times more fish. The explanation turned out to be purslane. Cretans ate it constantly, raw in salads, cooked in stews, sautéed with olive oil, fed to their livestock. The chickens and goats ate purslane. The people ate the chickens and goats. The entire food chain of the island was threading omega-3 fatty acids upward from a plant that grew wild in every field. When nutritional biochemist Artemis Simopoulos formally analyzed purslane in 1992, the numbers were striking. Fresh purslane leaves contain 300 to 400 milligrams of alpha-linolenic acid per 100 grams, 5 to 7 times more than spinach, 15 times more than iceberg lettuce. It is the most omega-3 rich vegetable source ever measured. More unexpectedly, purslane contains trace amounts of EPA, eicosapentaenoic acid, a long-chain omega-3 normally found only in marine organisms. Land plants aren't supposed to produce it. Purslane does. When Simopoulos published this finding, skeptical researchers suspected contamination. Independent analysis confirmed the result. Beyond omega-3s, the nutritional profile continues to impress. 7 times more vitamin E than spinach, 6 times more beta-carotene than carrots, and significant concentrations of melatonin, potassium, magnesium, calcium, and glutathione. A clinical trial called the Lion Diet Heart Study tested what happened when heart attack survivors adopted a diet rich in these compounds. Half the participants followed standard low-fat cardiac guidelines. The other half ate a Mediterranean-style diet incorporating purslane, walnuts, and other omega-3 rich foods. After 5 years, the second group had 70% fewer deaths from all causes. The trial was halted early because continuing to keep the control group on the standard diet had become ethically unjustifiable. In 2022, a research team at Yale led by Dr. Erica Edwards published findings in Science Advances that placed purslane in a category entirely its own. To understand the discovery, a brief detour into plant biology is necessary. Plants have evolved several different strategies for photosynthesis. The most common, C3, works well in mild conditions but loses efficiency in heat and drought. C4 photosynthesis, used by corn and sugarcane, handles high temperatures better but still requires substantial water. CAM photosynthesis, used by cacti and succulents, is brilliantly water efficient. Plants open their pores at night to collect carbon dioxide, seal them during the day to prevent water loss. But the trade-off is slow growth. Scientists knew purslane used both C4 and CAM. The assumption was that it kept them separate, different systems in different parts of the leaf. When the Yale team mapped gene expression at the cellular level, they found something no one had seen before. Both photosynthetic systems were operating simultaneously in the same cells. C4 during the day for rapid growth, CAM at night for water conservation, the products of the CAM reactions feeding directly into the C4 pathway. No other plant species on Earth does this. The same cellular machinery recruited for different biochemical tasks at different times of day within the same cellular space. Edwards described it as a genuinely rare combination of traits, a system that delivers both speed and drought resilience without the usual trade-off between them. The practical result is a plant that grows vigorously on roughly a fifth of the water corn requires, thrives in soils with salt concentrations that would kill most crops, and continues accelerating photosynthesis at temperatures where soybeans shut down entirely. Purslane is not difficult to identify. The stems are smooth and distinctly reddish. The leaves are thick, paddle-shaped, and succulent. When you break one, it releases moisture. The plant grows flat and low, spreading outward rather than upward. Tiny yellow flowers appear tucked between the leaves. The whole plant has a slightly lemony, mildly salty flavor that works raw or cooked. It's edible from the moment it emerges. The first 6 weeks of growth produce the most tender leaves, best eaten raw in salads or added to smoothies. Older plants hold up well to brief sautéing with olive oil and garlic, or stirring into soups and stews at the last moment. Across India, Greece, Mexico, Turkey, China, and much of the Middle East, it never left the kitchen. If purslane is coming up in your garden beds, consider leaving some of it. If it's growing in your path, harvest it rather than pulling it. One plant produces hundreds of thousands of seeds, each viable in the soil for decades, so a single season of letting it flower will ensure it returns. Half the world continued eating it. The other half learned to call it a weed. The plant didn't change, only the name did.